Neat. So according to the YouTubes, I am live right now, so I'm in the process of sharing the live stream link on the various Slack channels. So one moment, please. Oh, neat. I got an email from YouTube saying, oh, you're live now. Okay, design. I'm going to share, blah, blah, blah. Yeah, that seems like a good place to go. Cool. Already shared there. Design systems. Where else? Oh, yeah. Why not? Sharing with IO. Cool. Shared it on the various team channels, I believe, and we should be good. Hello, everybody. Hope you are doing well. It's been a while since I've done a live streaming thing, so I'm very happy to start doing this again. How do I switch this? Hi there. Yes. I have to reacquaint myself with my setup. So my computer, my handy dandy little laptop is on there on the right-hand side. I'm looking down there just because I have my streaming software, OBS, open there, and that's like my little control panel where everything happens. And it's also the screen that allows me to see live chat, maybe? Oh, come on, how do I see live chat on this thing? Every single chat is disabled for live stream. What? Why? Why is chat disabled for live stream? No way. Really? How do I enable chat? Oh, come on. YouTube, why are you doing this? How do I live chat? Enable live chat. Enable live chat, save for this live stream. Oh, that's such a bummer. Why? How do I enable the live chat? Well, this sucks. Okay, I'm not gonna end the stream. This is a big bummer. So I guess I will respond via questions and comments inside of Slack. I am so sorry. I don't know why live chat is disabled, but I'm going to proceed with this as planned. Regular programming. Here we go. Hi, my name is Q. It is February 12th, 2020. Brand new year, first live stream of the year, and today I am going to be doing something interesting. I am going to be taking a look at a piece of UI that I didn't design, and I will kind of deconstruct it and figure out and analyze and break down how it is a UI engineer would go about building it. So I'm going to share my screen. Again, apologies that the live chat isn't working. It'd be so cool to talk to you guys, but it is what it is, I suppose. So here is the UI. It is very fancy, lots of stuff going on. And how did I find this? All I did was I went on Dribbble and I searched up animation UI or something like that. So the scenario is, let's say this person, Anton, has created this lovely high fidelity, completely animated mockup and is completely happy with it and is ready for development. Anton is handing this to me, the front-end engineer, the UI engineer, and then now I have to figure out all the things that is required to constructing this UI, all these interactions. So for context, anytime you go to Dribbble and you see these very intricate, very highly interactive demos of interactions, they're almost always created with After Effects, Adobe After Effects. It's not HTML, CSS, and JavaScript used to create this thing. It's not Objective-C, it's not Swift, it's not Kotlin used to construct this. This is pure just like, oh, I'm in a video editor and I'm going to construct this UI, and I can confirm this because I looked through the comments of how Anton did this, and he mentioned that he uses After Effects. The other one that I've seen people use is this application called Principle. Again, it's you bind things together, although you're using screenshots and stuff. You bind things together in a very video timeline-y kind of thing with keyframes and whatnot. I think Framer used to kind of do something like this, maybe not anymore, but in any case, what I'm trying to get at is these very, very gorgeous animations aren't done in a way that's immediately transferable to code. The closest thing that you can get from I built this inside of After Effects and let's render it inside of code is to use this library from Airbnb called Lottie. What it does is it's basically is a plugin for After Effects that somehow transforms everything into data that Android, iOS, web, React Native, and I suppose Windows knows what to do with it so that it can render those animations on that particular platform. Very involved, very heavy, but also at the same time, you don't really get that, I think, too much of that interaction kind of thing. You get to see the movie play of this animation, sure, but you won't be able to get too much of that, what you're seeing right here. If I swipe, something happens. If I add an item, something happens. You don't get too much of that. You don't get too much interaction. You get a lot of visual, which is nice. So that's a scenario. Me being the UI engineer, I'm seeing this and I'm going to be like, all right, cool. I need to dissect this so that, well, either I know how to build it or I can create some sort of overview so that I can work with the designer or the engineer so that we can all build it together. And here's how I'm going to do it. I'm going to take a bunch of screenshots. I'm going to put them into this Figma file. And this Figma file the link is available in the YouTube video description. I've added it there. If not, I will add it there later on so you can follow along live if you would like. So here we go. Immediately what I'm seeing, and I have a pen. This is very important. Whenever I do these things, I always use pen and paper just to write down my ideas because I need to scribble a lot. Or in this case, for live streaming, I'm going to use a tablet of some kind. Hopefully you can see my mouse. Yeah. How do I zoom in? Yeah, so I can do one of these. Oh, no, that's too much zoom in. Okay. So the first thing I notice is that the shoe, this card here, it starts off as a rectangle and then it expands into a circle. So that is one thing we need to build. So I'm just going to copy that, screenshot that. And I think those are the two screenshots we need. I'm going to try to screenshot this swipe interaction. There we go. I think I caught it. Okay, I'm going to plop this into Figma. So I did do a test before this thing just because I need to figure out if I can draw inside of Figma, which I can. And I'm really hoping that you can see this in the live stream just because, let's see, it's not as zoomed as I would like it to be. So I'm going to try drawing my pencil. Hello. Yeah, you can sort of see something on the screen. I'm looking at my video feed right here. There's a little bit of a line. I wish I can make the strokes a little bit bigger. I can't. I tried. You can make them bigger after the fact, but not just as a default stroke size, but it's fine. Okay. All right, so I have some screenshots available inside of Figma that lets me break things down. And just a heads up, some of the things I'm going to be talking about may seem brand new to you. Maybe these are things you've never considered before, which is great. That is the entire purpose of this exercise. Ooh, Slack. Let me see. Maybe there's some chat going on. Maybe not. All right, cool. It's fine. Cool. So what do I need? So somehow this square, or this shape, has to transition into this circle. How does that? So in order for a fluid transition to happen, we basically need this shape to become, to become a giant circle. How do I make a circle inside of Figma? It's ellipse. All right. So this shape has to become this shape. It's one shape. It's not two shapes. That's important. So immediately, for this transaction to happen, this has to become this. And then if you were to navigate back, so if I were to navigate from this screen, which is, say, an individual singular product view, over to this main kind of indexy view, therefore this transition has to happen backwards. So when you think, and for context, I'm going to move forward in describing how we build this thing in the context of web. So the principles are the same, whether you approach it from web, iOS, or Android, but the terminology and the particular libraries and technologies will be different, but the principles are the same. So you have different screens or different views. I'm navigating from this index view to this singular view. This shape behind the shoe has to transform into this, but it also has to transform back. So you might be thinking, oh, the trigger mechanism that changes this, that makes this square into this circle is a click, which makes sense, right? You're tapping on it, you're clicking on it, and then it becomes this other thing. But that, I would argue that's not necessarily the case, because when you have an application and you have multiple views, those views are typically segregated by a URL of some kind. If there is a URL, therefore there is a router of some kind. And again, this is the context of web. So we have a router. So the, let's say, oh, how do I make this font bigger? Please, oh my goodness, please make the font big. 32. No, it needs to be bigger. 56. No, it needs to be even bigger. 92. Okay, cool. So your application has a router of some kind. And what the click actually does is that the click routes you from the index view to the single view, and that change in route, that is the thing that triggers the animation, if that makes sense. So now if I'm here, right? If I'm here, and this guy, pencil, zoom in, you can see that there's a back button, right? So if I click the back button, it should then change the URL from, say, shoes/ID back to shoes, and that triggers, again, the router, and then that triggers the shape transform. So therefore, the shape, which exists in this kind of floating layer, the transition of it is triggered by a route change, not by a click event. That is a very important detail, which means that somehow you need to I can't draw with this mouse. Somehow, Figma. Somehow you need to translate route changes to animations. So the framework, the library that I'm most familiar with is React. So typically you would have a router like so. Route at the surface level of your application, the main entry point, and then you have a switch, right? And then the switch, you have an individual route that's like how to path is blah blah, and then it renders some component of some kind, right? Yeah. And then this, let's say this component is shoe index. This component is just a shoe, right? So the switch, when you switch from one to the other, somehow the animation, the triggering of the animation has to be layered in between the route and the actual component somehow. So you need this mechanism built in. You need some sort of animated route system that you need to build. So that is the first system that I've introduced. So animated routes. And again, and this is just, as I walk through this, I'm going to be introducing and talking about a lot of different systems. So here we have animated routes, the thing that binds routes to animations. And because this this interaction that we want, it's very, very animated. We shouldn't write, like, again, context of web, we shouldn't write CSS animations kind of ad hoc. So as we see it, so like, oh yeah, the shape randomly transforms from here to here, negative 30 pixels or something like that. We have to think about things in a more systematic level. And I can tell, and usually when you want to think about animations in a more systematic level, you have to introduce an animation engine of some kind. So here, so animated animation engine. So what do I mean by that? I think a really good go-to animation engine would be anime.js. Another one would be Greenstock or GStop. There's a cool little screen there. Animate.js. For React, there are quite a few popular ones. So React Spring, that is one that's used inside of Gutenberg. It's its own very complex animation engine that does a bunch of fancy things. And the reason why this is important is because animation engines, they have a lot of sequencing and callback hooks. What I mean by that is when you have just standard CSS animations, you don't have a lot of control as far as when an animation happens, how you cancel it, and when an animation ends, how do you control all that stuff. With animation engines, they expose the life cycles of animations so that you can then trigger them or bind them to certain other systems. So in this case, we're leveraging our internal animation engine thing, and then we're from that. Can I draw an arrow? Shift P. Yeah. So from that, we're going to use that to build our animated routes thing, which is then hooked up to a router system. So we have a routing system, we have an animation engine, and now we have our animated routes. And with that, we have the necessary trigger mechanisms to tell, hey, square, transform please into the circle. And then the circle can then transform into the square. And that is just the mechanism that is triggering it. We also have to know, how big to transition this particular shape to this particular shape. The benefit of working in the context of mobile is that basically you almost always know the size of your screen, right? It's always, let's pretend as your application is portrait, is usually in portrait mode. It's always this large rectangle thing. So you have a lot of control over that. But for web, your browser may be, I don't know, a range of different sizes. So why that's important is because right now, this particular shape is in the middle of the screen. And how that is rendered into the screen, the values are initially unknown, right? You're not saying, oh, absolute this position, this guy 50 from the top and 20 from the left or something like that. The starting value of this is unknown. This is unknown until it renders onto the screen. And then with JavaScript, you can then calculate, oh, this is, I can't draw. Oh, this is, forget this tablet thing. It's not working out with it. I'm going to use my mouse. I use my mouse to draw for years. So yeah. So after it initially renders, then we can get the values. Then we can understand how big something is and how the distance it is from something else. Based on the initial values, we can then determine, oh, when this shape needs to transition to this shape, it needs to move from here, center point, to about off screen, right? So the center point of it is now somewhere around there. So it needs to move from here to here. Hopefully you can see the thing I'm drawing. So that means during this animation phase, we need to somehow understand the size of the shapes and how much to transition from state A to state B. So nowadays, I think when people have started to realize, oh my God, it's very difficult to dynamically calculate these values, libraries and techniques have started to come out. So depending on the library that you use, they may allow you to interpret values on the fly. So what I mean by that is, let me pull up Visual Studio Code. So in the case of anime.js, I know you can do this. Let's say they have a callback hook called update, right? and they have a function. I'm writing pseudocode in here. So maybe one of the props they give you is like element or node, and the element means the actual DOM element on the screen. So with that, you're able to get the size of the thing using this is the go-to method, get bounding client rect. Okay, and from that you can get the x, you can get the y, you can get the width, you can get the height. And with that, with those 4 numbers, you can then calculate the exact position of the thing, and also the right-hand offset and all that kind of stuff, and also the center point. So with that, you understand the size of you have the initial starting values. Now you need to know where it needs to go, right? So with this particular UI, you can make some assumptions, right? So the starting size of the thing, maybe let's just say it's 100 by 100. And the next size, this big circle, let's say you know the value, it needs to be 400 by 400. So let's just pretend there is a render next callback that you can give. So render next would be, let's pretend that is like the thing where you tell the animation library, oh, so these are my starting values. I want you to render then the width to be from 100 to 400, the height to be 100 to 400, and so on. So then, this is my favorite part, math happens, okay? You get new values, next x, next y, next width, next height. Based on math happens, and now you have this. And then now you know where it needs to go, right? From here to here, from this shape to this shape. You then pass all those values into your the animation engine for it to render to the next thing, and that's what it'll do. So this process of like dynamically calculating values, I believe it's referred to as interpolating. So animate.js has this update hook, and also for the ability for you to measure the size of the thing. So in the case of React Spring, depending on the hook that you use, you may or may not have access to that. And I think because of that, they've actually released React Use Measure. Yeah, they've released this library that allows you to dynamically measure the size of your shape during the animation phase that allows you to transition from A to B. So now we have another system. We need some sort of we have the animation engine, we have the router, we have the animated routes, and we need some sort of measuring system. I don't know what to call it, but we would call it that. This then allows you to do the mathing, or rather, this is like the animation interpolation system, aka measuring if you need. Yeah, so this is the guy that allows you to transition one shape to another that is initially triggered by the animation route change. All right, so that is routing and animations, and we just got started. What is the other thing that this thing does? Right. Okay, well, there is a gesture system, right? If you're working inside a mobile, you get that for free. But with web, that's not the case. You don't get that for free. The browser APIs don't give you enough events to be able to simulate gestures and drag and all that kind of stuff. They have all the little parts that allow you to assemble that kind of thing. But there is no gesture system for the web. So you could leverage a library, I believe, Use Gesture, again, by React Spring. Takes care of this. This is something I've used a little bit in the past, and it works very well. They've simplified things a lot. So you then need a gesture system that allows you to basically do this swipey carousel effect that you have from this initial, that gives you this thing here. So that's the other thing. Now we have some UI stuff. So now you have a carousel component. Okay, The carousel component is a thing that is renders all the different items, does the offset, and is swipeable, or is like allows you to go next and previous using the gesture system. Or I guess in the context of web, I think there's a little arrow here. You can click left and right, and then you'll have all that stuff kind of built in. And the gesture system and how these things animate from one to the next, right? You can see there's lots of fancy things going on right here. We need to leverage our animation engine now that we've either built it or used a library or something. We've established that there's an animation engine in there. So the animation engine needs to be leveraged by the carousel in order to handle the swiping of items from left to right. And there's a lot of things that happen. You can see here as the thing. Oh, come on. I wish I can play pause. I wish there was a video so I can play and pause. Okay, so maybe I can capture this. No, it's too fast. So as the animation starts, the card kind of does this tilt, this 3D tilt that happens, and as it slides, the shoe slides at a different rate compared to the actual square itself as it transitions from current to previous, and the next one kind of does the inverse of that as it comes in. So this is all handled by the animation engine, but you have to be aware of the various layers in order for you to time and for you to sequence the animations that happen. So for let's say this is the can these guys have strokes? Yeah, strokes. Yes, great. Make the stroke 5. Yeah. So let's pretend this is a shoe. Let's pretend this is make it red for now. Okay. Let's pretend this is a card, right? So every single carousel, and by carousel I mean this is like a generic carousel component that you may have inside of your application, your design system, or whatever it is. You have a generic carousel thing, and within this very specific shoe page, you have a customized version of that allows you to render the items that have these kind of shoe offset card thingies that are happening. So as this thing, as you have your items here, right? Let's try to imagine the animation phase for this thing. This is the starting animation, what you're seeing. As it transitions from left to right, I believe, can I just drag this one? How do I just want to drag this point. How do I make an oblong kind of shape in Figma? Oh my goodness. Is there a vector editor? Pen. Is this it? Oh my goodness. Okay. Well, looks like I'm not able to do that. I just want to select this individual point. Oh, great. Something happened. Great. Cool. Don't touch anything. Okay. So you need to be able to, we acknowledge that these things shift or have different layers, enabling you to render something like this. So inside of web, how you would get the shape is that you can use CSS transforms, and I believe the property that you need is perspective, and that allows you to kind of get this 3D kind of transformy effect, right? So this is, we have to break down the sequence. So that is start, and now we have the transitioning effect. And as it comes in, it maybe gets less like that. Okay. Let's just pretend it now looks like this. But as it comes in, the shoe, there's a slight delay. There's a slight offset to kind of create that kind of layered feel. Let's just take a look at this animation again. Yeah, the shoe lags a little bit behind the card. So that means that there is a stagger that happens. And staggering inside of animation basically means that you have different items animating at different times. And the thing that sequences the stagger is an animation delay of some kind. So we have a single item, which is this card and shoe. We have an animation trigger, which is the swipe gesture, which is powered by the carousel. And then we have the animation that plays, the enter animation, if you will, like the enter meaning it's off screen somewhere and now it's entering into it being the active item or something, which we have two different objects that animate at different times with the stagger. So now we have this, and then that becomes this, right? So that is what's known as the enter animation. So different libraries, they make this very explicit. So if I go to, say, React Spring, inside of their use transition, they have an enter phase, allowing you to manipulate the CSS styles as you see fit. Anime.js, I believe they have something similar as well. So this is the enter animation for your card and shoe thing coming in for an individual carousel item. It coming out is basically the inverse of that. So that is the exit animation. So we start with that, and then I believe this starts getting like things move. So this starts getting pushed like this. This now becomes inverted. How can I flip it? Flip horizontally, flip. Yeah, so that becomes that. And then now we have a successful exit of the shoe guy. So, with this being said, me as a UI engineer, breaking down this animation very, very carefully. I have to know a couple of things. I need to know the values, right? Not only the size of the square, but how much to do this perspective change by. I need to know the animation timings. So how long does it take to do the complete animation for enter? I need to know the stagger duration, the animation delay between the shoe and the card. And I need to know that whether when you do play this thing in the inverse, that is the exit animation, if all those values are the same but inverted. If not, then this is something that you would coordinate with the designer on to nail down those values so that the animation feels really, really good and tight, that match the thing that they have constructed inside of After Effects. The other thing that is a very, very minor detail. Can I zoom in on this thing? Yeah. Oh, no, don't do that. Okay, I gotta watch it. Okay, pay attention to the card thing on the left. When the card comes in, right, it doesn't just snap from, I drew it in the inverse. I apologize, I think, but it's fine. It doesn't just snap from this to this. There is an animation easing of some kind, but it's not just ease. It's not just a straight up CSS animation. So I'm gonna try drawing again. Pencil. Okay. Hopefully you can see this. Oh my goodness, the stroke is so thin. How do I make it not thin? Ah, geez. Figma! Stroke 10. Yeah, why can't this be the default? Because now when I draw again, it won't do that. No. Pencil. Yeah, it doesn't do that. I apologize. Yeah, that's no good. Okay, hopefully you can see this. So then a standard animation linear looks like this. It's just a straight, right? Amount of animation over time. Some math stuff. Easing kind of looks like this. Start slow and then finish fast, or start fast and then finish slow. This particular effect, it's the animation, if you can imagine the chart, looks kind of like this. Oops. Right? There is an overshoot that happens, and then there's a spring that pulls it back, and then it kind of does this little wobble. That is not something that you can achieve out of the box with CSS transitions or CSS animations. That kind of easing does not exist. You could kind of fake it with a custom cubic Bezier, but in order for you to do this kind of thing, if you have an animation engine, typically they provide you what's known as a spring animation. That is the entire concept behind React Spring, is that by default, their animations use physics to control the animation. So here, Spring is basically a mathematical something of mass, tension, and friction. This is a really good little demo that allows you to kind of play with it. That's right. So the less tension something. Oh, come on, play. I think the screen sharing thing is bugging it out. Yeah. So if there's no friction, there's lots of springiness, right? The thing, the square now looks like this. But once you add friction, it's slower. You're pulling it back. It takes a little bit longer to get into place. That being said, I'm not an expert in this. I know the overall high-level principles of the spring animation thing. I don't have a lot of experience with it, so I won't be able to know the values off the top of my head to achieve a certain something. I always need to use a playground of some kind in order for me to fine-tune the values. What's interesting about this is React Native animated spring. Cool. I don't know too much about native development. By native development, I mean actual Swift, Objective-C, Kotlin, Java for Android. My only context into that world is briefly skimming over their documentation for iOS development and also React Native. So for React Native, they give you this Spring animation for free. Because Spring it's a very common thing that you would see in the world of mobile. Not so much in web, but mobile, this kind of fluid, nice, slick kind of animation thing, that's kind of expected in the world of mobile, just because that's how Android and iOS have done it for so long. So they provide you with this Spring mechanism, this Spring animation out of the box. And for web, because we don't have this, we have to leverage the libraries like React Spring or perhaps another animation engine to simulate that very complex math and physics that we now get for free. I won't even pretend to understand the amount of math and physics that go into creating the velocity that is a Spring animation. I just know that Spring animations exist, and that's probably all you need to know as well. It's a thing that makes it bounce. Just say bounce. I just need the square to bounce, and bounce, Spring animation, there you go. So yeah, there has to be some sort of Spring animation inside of our animation engine. That is the next thing. With Spring Bouncy support. So depending on the animation engine or the animation solution that you have, you may not have Spring. So you'll have to somehow build that in if you want to achieve the thing that you're looking at right here. So I think we're basically done for the left-hand side, right? We have so a lot of things that happen. We have the router, we have we established we need an animation engine, we need animated routes, I apologize. We need some sort of interpolation system or measuring system so that we know the values to transition a shape from A to B. We need a gesture system that allows us to swipe. We need a carousel component that is a generic component that exists within our application or design system, whatever, that allows us to render these individual items. So for the items itself, we've established this is the animation sequence it requires. There's two different layers with staggering effects so that the shoe and the card renders in at different times. And with that, the animation needs to be played with the Spring animation, something that gives it bounce. Okay. Let's move on to an individual item now. So one really, really important thing that needs to be called out here is typically for routes that transition, what happens is, let me jump, nope, VS Code, yep, yes. So when you switch from one route to the other, like if this thing was built like this, everything that had rendered within the index page, that is this, right? Everything will render here. Once it changes from this to a singular page, everything you see on the index page will be thrown away. And then the single page will be re-rendered, which is fine. Right? I mean, that's how websites work, right? You navigate from one to the other. The very, very hard part, though, is if routes were to change, how do you preserve elements so that they stay on the screen that allow the transition to happen from one to the other? So that means inside of your component, inside of this screen, right, you may need several switches happening. So therefore, if I'm just imagining, right, this particular screen right here, I'm just gonna very quickly break it down. You have your screen. Please have a stroke. You don't have a stroke. Yeah, 5. Right. Okay. Cool. You have your overall screen. Now I'm gonna break this apart. What preserves? What stays? Nothing. Just the item. Just the shoe and the shape. Everything else kind of goes away. Okay, that's fine. So I have what am I doing? Figma. Yeah. So the shoe, the shape and the shoe, that is the thing that stays. And everything else goes away. So let's just pretend this is the listed content. Let's pretend this is like the head nav, the header nav, whatever logo thingy. All this stuff, I'm going to color this something different. Right. The non-red stuff are the things that can transition out. But this stuff here is the thing that has to be preserved. Therefore, there has to be multiple switches. There has to be one switch that takes care of this content, this bottom content, one switch that takes care of this guy or anything else that may appear in the top header area, and then one switch explicitly for the shoe and the and the card. Maybe it's not even a switch at all. It's another component that can stay there, but is aware of route changes so that it's not thrown away, it's preserved, but it's changed. So this is a really important detail. This is something that I ran across when I built a very similar UI previously, where things weren't broken up into various sections based on route switches. We just basically had one giant switch that transitioned from page A to B, which meant that certain components, like you can imagine a header bar, or in this case, a very fancy shoe that stays on the screen, it can't be preserved because it's when one page is, if you imagine just a standard web page, not JavaScript driven, just like a PHP or Rails or whatever web page, if you transition from one page to the next, about page to contact page, the entire page reloads, right? A server-side thing happens. All the page content is reset, and then the new page loads. That's basically what happens when you do a JavaScript-based route change. But we can't have that. We need the things to stay on the screen. So there has to be some sort of mechanism that enables that enables elements to be preserved during a route change. It's a very tiny detail, but it's so important that this is nailed correctly. This could be part of your animated routes system, where it can handle the preservation of elements when you transition from one route to the other. So that can be part of it. Right. So now this animated routes takes care of two things. It takes care of the shoe thingy, and it also has some sort of switch mechanism built in, so that other elements on the screen, like this discover and this more or whatever, they can move alongside. So you can choose to preserve the element or not. That has to be built into your animated route system. Okay, now we're on an individual index page. How long has this been? This has been 40 minutes so far. Hope everyone's doing okay. Okay, now I'm looking at the shoe and the individual index page. Okay, it swipes, and then, come on, click on the thing. Okay. Anything fancy happening? Nothing really. So the only fancy thing is happening here is the UI of this guy. Come on, I just want a pencil. Okay, the UI of this guy, right? The 8, the color changes, the background changes, and then when you press the button, this thing does a kind of depressed animation. So those animations, they may rely on the animation engine, they may not. It's not too crazy, the things they need to do. But the main thing is, are these components currently built? Right? Or are any of these components currently built in your application or your design system? If not, then you'll need to build them. So I'm going to assume that the majority of these things are already built. And for this particular task, our thing is to focus specifically on the complexities that has to do with animations and animations based on interactions. So I'm not going to say, oh yeah, we need to build a button, we need to build a header component or whatever. I'm going to assume that all that stuff is already there. If not, well, as a UI engineer, you're going to build it, or you're going to create a task list for your front-end engineers or whoever to start building that thing, because you'll need it for this guy. So again, this is more of a mobile thing. There is an overflow that happens, right, for all the various sizes, I'm guessing. So you can swipe left and right to see the various sizes. On desktop, you can take care of that with horizontal scrolling. Oh, that actually raises a really good point. How do we handle this on desktop? So let's just pretend that there are like a bunch of different sizes. So regardless of, so when you have a relatively normal kind of browser window, there might be some overflow that happens, right? Therefore, there is a horizontal scroll bar that happens. On desktop, how you scroll the horizontal scroll bar is if your mouse happens to have dual scroll wheels, so like maybe one on the side, then you can use that. The alternative is to use Shift. So here, so in Figma, if I scroll just in regular up and down, it goes like this. If I hold Shift, now it goes left and right. But I mean, for this particular interaction, not everyone will scroll left and right. I mean, as I'm looking at this thing, I'm going to pretend I'm browsing on this on my browser, and there's lots of different sizes that may be cut off by this carousel looking thing. A nicety that you can build into this is, if you happen to scroll up or down on this particular bit of UI, I'm going to draw a rectangle. If you happen to scroll up or down within this little chunk of UI, then what you need to do is you need to basically simulate horizontal scrolling. Okay? So if you want to build that, then you need some sort of like, I don't even know what to call it, scrolling system, where you can basically remap vertical to horizontal. Right. So you basically need some sort of scrolling system that enables that to happen. And then that scrolling system can be built into your carousel component. Let's pretend it's the same carousel that you have here. And that could be triggered on and off based perhaps on a prop flag. Like something like carousel is horizontal scroll bar. I don't know. Some prop name that you'll come up with. I'll get back to this at the end. But when you pass in that flag, then the carousel system knows, okay, I'll just remap vertical scroll to horizontal scroll. My tablet just turned off, that's fine. And then that can handle that interaction. It's a very nice to have, not necessary. I've done this before. It's very tricky though, just because depending on the browser and the device you use to do the scrolling, it's not always straightforward. Just because, for example, on a trackpad, right, when you scroll, the thing you're detecting for is Y. Y is vertical, right? Y is vertical scroll. And there is a event within JavaScript called onWheel, which is with the wheel thing. And in addition to the Y value that it provides, it also gives you, I believe, delta Y. Delta Y is the difference between the previous scroll value and the current scroll value. So if you scrolled up by like 1, the delta Y might be like 1. That's all that means. So every single scroll tick, depending on the distance, you'll get a larger or smaller delta Y. So if the delta y increases, that means you know they're scrolling down. If it decreases, they're scrolling up, right? More y go down, less y go up. I might have inversed that, I'm not too sure. So so you can just safely assume, oh, okay, well, if they're doing delta y things, that means they are vertically scrolling. Then I'll just like convert delta y to x and just like force the thing to scroll horizontally, which is what you would do. But if you're using a trackpad, scrolling isn't always vertical. Just because people scroll up and down, they swipe in a diagonal fashion. That means there is delta x that happens. Or x is not always 0, right? So then you have there is, if you look online, there is like mathematical formulas where you can kind of consolidate and kind of do your best guess as to whether the person is their intention is scrolling y or vertically or horizontally. So you would then leverage that inside of your scrolling system, and then you would leverage that inside of your carousel system, and then you have a remapped, very nice to have, horizontally scrolling carousel within web. Right, so now we have a scrolling system. And the last piece, and I think that's it for this particular single view. I'm just taking a look at this now. Okay. Cool. So that there's something else I just noticed. So this is more of a challenge for web than it is for native. Native, you get this kind of thing for free. What I mean by that is, let's say this is your initial index page, right? I'm just going to use shapes to kind of illustrate what I mean. So inside of native, when you navigate to another page, this other page kind of like does this kind of thing. You might have seen it when you use your like iPhone or whatever, right? This other page goes on top like that. So when you navigate back, this other page just slides away. And then now this is like thrown or something, like it's no longer needed. But the original page is always there. It's always there during the during this navigation phase that happens. For web, typically what happens is you have, if you're using a switch within your router, you have one or the other. Right? You have your index page, and this is shown. If you switch to a singular page, then this is thrown away, and this gets rendered in that place. Well, we can't have that here because, let's just take a look-see. Right. This page, you see it render in, but the moment you hit back, you have some of this content that used to be here. It kind of does an animation, it does something, it like folds or whatever it is. And anytime an animation happens where you see multiple things at the same time, like the previous screen and the current screen, right? There has to be something within your animation system or your route transition system or something that by default keeps the pieces. Otherwise, you can't transition from A to B. You just get either A or B. And the word I use to describe is this babysitting of all these various factors, of all these various elements of the life cycle of when the transition happens, or all that kind of stuff. It's something that you really need to build within your animation engine, because trying to write this every single time is an absolute nightmare. So I can show you. There is, let me just show, let's see. Okay, let's just take this example. I don't know what this looks like off the top of my head. Oh, this is actually quite nice. So that's not too bad. Or maybe they've really updated their examples. Okay. Yeah, their examples used to look way more verbose than what you're seeing right here. Anyway, so typically, if you don't have systems that kind of do this for you, then you'll start seeing a lot of this like functional math that you need to write in various areas in order to rig this thing up to happen, which you'll probably get in the end. But you know, once you've designed something like this becomes an established pattern inside of your application, right? So you'll most likely need to use this again somewhere else. So it makes sense that this nonsense babysitting of all this stuff is, you create a module or something that just like encapsulates it all, so you never have to think about it and write it again. And that could be a piece of your animated routes system component. That may not be, but it's something to be very mindful and aware of. So some sort of route transition navigation system, something like that, which works in tandem with your animated routes or your route switch or whatever it is, in order to facilitate this back and forth navigation animations to occur. And we have our last piece, and that is the screen you see on the very left. Sorry, the very right. Oof. And that is when an item is added and removed within a list. It may seem simple, but it's actually totally not. So there's several things that's happening here. So you have a list of 2 things, let's say. And then all of a sudden you add an item to the cart, and now you have a list of 3 things. For UI on the web, typically on the web, this transition, there is no real transition, right? You just plop the item in there and then that's all that happens. That's just because this is easy. If you wanted to gracefully animate the thing in here, like that, like what you just saw right now, there are multiple steps that is required to make this happen. And thankfully, we have our animation engine, we have our animation interpolation system that can help us with this. So basically, you need to somehow, this is the start, this is the entering, this is the entered for adding a brand new item. When an item is added in, you need to calculate the height that it's going to be. Because when it first is added in, the height is 0. So it looks like, it's like, let's pretend this is 0. It's like very tiny, right? It looks like that. So the starting height is 0. The final height is unknown. You have to calculate it. If you're blessed and you have fixed height items, then it's fine. You just like, oh yeah, 0 to 80. If not, then you'll need to use that measurement or interpolation system to figure out the DOM node that the height needs to be at. So, okay, brief calculation, get bounding client rect or whatever it is. Oh, the height will be 120. And there is something that needs to happen between the original 0 height and the original 120 height is, well, you need to hide it when the calculation happens. What I mean is, this is a sequence, right? So let's say sequence 1 is not rendered yet, therefore height is 0. Sequence 3, rendered. Height is, you calculate it, calc, and now it becomes 120. You can't, there is a step in between. Otherwise, you just straight up see the card go like that. Just because that's how it renders on the screen. You see the card and it just plops on your screen. So there is a step in between. There is rendered, immediately, hide slash overflow hide element. So what I mean by that is the element renders in, but the containing thing forces the height to be 0 so that the user doesn't see the element. So if I can jump back to Figma, it might look something like this. You have the element that gets rendered in, but the container of it is height 0 or something like that. So it actually hides the element, but it's rendered there so you can calculate the height of 120, right? So this step to this step 1 to 2, it should be invisible to the user. There should be actually step 1 to 3, visually, it should look like nothing happens. So now step 4 is apply the 120 height. So now you apply, using your animation engine or whatever it is, height 0 to 120. And then you play the transition. Oh, wait. There may be a step in between here. Yes. You play the transition and then maybe a 5.5 or kind of 4.5. Show the element, right? So just before you play the transition from 0 height to 120 height or opacity 0 to 1, you then trigger something that allows it to show or to render. Otherwise, it would stay height cut off by the container component. So then now the last thing is you play this transition. So this process of knowing the first values, knowing the end values, figuring out the differences, the math happens, and then playing it. This is known as flip, CSS, no, animation flip principle. Yeah, flip technique. Flip. Yeah, so this is a high performance technique for you to calculate the sequence of things I just talked about. The initial, the first, the last, the first values, the last values, inversion, that is the difference in between, and playing, that is the thing that plays the animation. So flip is a principle that I think was popularized by Paul Lewis, currently works at Google. Cool guy. And that is the thing that's required for you to animate this in, right? And that is the play sequence. The removal sequence is actually, it's like 2 times as hard. And here's why. Adding something within the context of React is easy, right? You have an array, you have objects, right? Const things is that, and then to add a brand new thing, you do things push, or if you don't want to do direct mutation, you would map the array or do whatever. It's fine. So then you push this thing, and now this thing went from 4 to 5. So if you were to delete a certain thing, how React handles it is the moment that, if you're looping through an array and you're rendering things as children, the moment something is removed from that array, it is removed immediately from the DOM. What that means for your animation is that your exit animation, the inverse of this, where you need to collapse it and go to 0, the inverse of this can't happen because there is no element for you to animate because it's removed right away. So you need something in between to control that mounting and unmounting interaction, right? It serves as some sort of middleware that allows for animations to play forward and to play in reverse before it is unmounted from the DOM. So with React Spring, they give you that with their, what the happened to my browser? So they give you this, come on. Did my internet break? No, just React Spring broke somehow. So they give you this mechanism using their use transition hook. It's a very special hook that you would pass your array in, and that serves as like an in-between for the render in, render out process, which means that enables you to actually play the exit animation before it is removed from the browser. Otherwise, the exit animation can't play. So yeah, you need some sort of, in addition to your animation engine, you need some sort of mount, unmount handling coordination system. Okay, Right. And I think that's about it. Let me just check this UI real fast. Yeah. Yeah, the other thing that happens is when you add and remove the shoe, the animation plays in like slightly different ways, but we've already taken care of that, right? We have our spring animation spring system that lets the shoe be bouncy. We establish that there may be some sort of sequencing or delay that happens between the background square thing and the shoe, so you have some animation timing that happens there. And now we've established that we need some sort of mount and unmount handling within our animation engine, so that our animation can play and can play while being entered and play while being the enter and the leave animations can play while items are being added and removed from a list. So yeah, that is, I think, a complete breakdown of all the various systems that's required to build this particular UI. There's other ones, of course, like how do you write styles and all that kind of stuff. I'm going to assume that our current application or design system already has something like this. These are maybe some brand new things. So from this point forward, the next thing that I would do is all the items that are listed here, right? I would double check with the front end team, hey, how many of these things do we have? Do we have an animation engine? Do we have a route transition system? Do we have a carousel component, and so on? And then between myself and maybe the front end engineer, we'll work out which ones we have, which ones we don't have. And the ones that we don't have, we'll explore. Can we leverage a library to build this? If so, great. Does it work with our current existing system? If everything works, cool. If not, what will it take to integrate with this third-party library? For example, let's say we don't have an animation engine and we want to use React Spring. Okay. Can React Spring gracefully be integrated into our application? If yes, great. If not, why not? And we'll figure out those nuances, right? And we'll repeat that step for every single one of these systems. There's a good chance that some of these things will need to be built. And the cool thing is, after you built this, and as part of your design system or as part of your application, you won't need to build it again, right? Once you have a gesture system, you'll have a gesture system throughout your application. Once you have an animation engine, that is a thing that you will use. And then based on what we have, what we don't have, whatever we need to do, that then establishes a project timeline for the dev cycle or for the sprints or whatever it is you need from the engineering side. So, okay, cool. These are all the various things. These are the dependencies. Here's what's easy. Here's what's hard. Here's how we're going to divide up the work and so on. So that is taken care of from engineering. For design, based on the conversations you've had with your front-end engineers, you may come back and say, oh, yeah, the transition that you have where the shoe shape here, I know you really love this transition, but the shoe and the shape being preserved between the index page to the singular page, it's way too hard. It's going to take us 3 months to build this thing for reasons. So this is where you would go to the designer, and then maybe you'll come up with a compromise. Maybe you won't. You'll just work with them. And your job as the UI engineer, assuming you're able to work with another designer and another front-end person, is you're the person that because you know all these various bits the best, you have to basically be the in-between all of them. Like making sure meetings happen, discuss constraints, what can we do, what can't we do, if we can't do it now, how can we do it later, make compromises for this particular design, wherever it is it makes the most sense. And once all that is hashed out, right, then the folks can start to build. So if you take a look at these topics here, there are things that are kind of, all these are, of course, are used in UI to construct this experience, but not all of them are directly UI related, if that makes sense. So for example, finding an animation engine and integrating into the application. That is something that, let's say a front-end person who's probably not too comfortable with UI stuff, so probably a hardcore JavaScript person who's excellent at like glue code API stuff, that's something that they can take care of. And so while they do that, you as a UI engineer, you can then work out all of these various animations that you need to do, work with the designer to nail this thing, perhaps in a separate environment or whatever it is you need to do. You can do this work concurrently, right? And this is like, for me as a UI engineer kind of person, I'm super excited about this stuff. Like, I love fine-tuning and tweaking animation sequences, making sure the UI feels like real. Like that is something I love doing. So you need to pair with a designer to make sure this happens, make sure the values look good, make sure the transition is good, everything is exactly like how they'd imagined and how they built inside of After Effects. So once that is happening, right, then the tricky part is when work needs to be combined together. That is something, again, you need to coordinate very heavily between all the folks to make sure that, this thing that we worked really hard on, it works and can integrate with the animation engine, and that animation engine works with our routing system and so on. And you just basically repeat this process throughout the entire development of this thing. And you, as the UI engineer, maybe you can focus on maybe some of the more difficult interaction kind of problems. So for example, creating a carousel component, it's quite complex, but it's probably something that the like a JavaScript person can handle, right? They can maybe use a library or create something quite simple to start off with an API that can be adapted and changed over time. But for you, the UI engineer, maybe the thing that you really need to focus on is the scrolling system. That is, we've established with the product person that this is an absolute must. We have to have remapped scrolling for reasons. That is something that you can focus on. And over time, as you build this thing, you now have the completed project. You've broken out and established all these various systems. You worked with all these various people, and now you have all this wonderful stuff. And the cool thing is, right, a lot of this stuff is reusable. Once you build this, I mentioned it before, once you build this stuff once, this is all you kind of need. And this just becomes part of your product creation, product design, whatever pipeline. And this may be part of your application. I recommend you abstract it out. So it could be part of your design component, your design system, your component library, or whatever. Something that is reusable. Just because it's a common thing. It's become a pattern within your application. And how I got into this whole thing is all this, for me personally, was really heavily inspired by the gaming industry. Just because they have to create all these various systems, so their characters, their AI, their all that kind of stuff can work. They have walk cycles, they have whatever it is that needs to happen within their game engine so that things just work, the player can play with the characters and so on. So, and I've also looked into animation, like film animation. They have a lot of this stuff as well. And I've adapted those techniques and applied it to the UI engineer work that I've done. It's been very successful, I think. The challenge is taking a step back and being able to identify all of these parts and systems. And I think that just comes with practice. So how I practiced essentially knowing what the pieces are, knowing what the systems are, where I either worked on directly with product that required something like this, or similar to what I did today, I would look at a Dribble thing or look at something on Behance and kind of think to myself, how did they build this? What are the various things that's required? So if this is new for you, then that's and if it's something that's interesting for you, then those are the things to kind of be mindful of, right? Try to think of things as systems and pieces that you see as parts, right? There is a system of some kind that allows for interactions to happen, makes things move. And the system is a thing that binds all the parts together. Identify what the parts are, identify what the systems are, and then kind of build and design and plan accordingly. So that is what I have for today. This was really fun. I like maybe I'll keep this up, make this a series or something. I don't know. I can find another kind of interesting UI thing and break it down. Shame. It's a gosh darn shame that chat wasn't working today, because I would have loved to like chat with some of you folks here. Maybe next time, once I figure out how to do it on YouTube live stream. But thank you so much for your time today. Hope this was helpful. I hope the recording of this was fine. Like my voice wasn't, I'm not screaming in your ear. I don't know. Again, new setup, new system. Need to figure this thing out. And yeah, thank you so much for your time today. And I'll see you soon. Hope you have a great day. Catch you later. Bye. All right. Click stuff to end the stream. What do I press? End stream. Are you sure you want to end the stream?